doesn't sound like it belongs there. So we have this deep knowledge. It's kind of a matter of is sort of the technical formal training what's really necessary? Or do we all have it in us? It's a question.
So we'll talk about it.
Sure. Just one more question I had for you, Steve. When you're learning something like that, I mean, you mentioned you have this internal beat.
Yes.
This internal four, say. Is that pretty essential to how you hang the rest of the notes around, or?
Yeah. I mean, when I learn music, and of course this is a difficult thing to describe because it first place takes place over a very long period of time. This piece for 2 minutes took a month to learn, to memorize. A month of daily work, maybe just 45 minutes a day, not all day, but a month of work on this piece. And so it gets assembled so slowly that you need an architecture upon which to hang this, because otherwise your memory just doesn't work. And it literally, you feel kind of paralyzed at the drums, because at first you think, okay, it's literally, okay, hit this drum first, and then hit this drum first, and then count to 2, and hit that one, and then do that. And I'm sure the sounds coming from my studio are just boom, long pause, sound of coffee brewing, boom, things like that. And so at that rate of learning and at that rate of tempo, the tempo you have to practice it at, if you don't have that internal architecture, you don't actually really know where to place the beat. Furthermore, you can't tell whether it's right or not. The internal architecture of beat is the test mechanism by which, one of the test mechanisms by which a musician will say, oh, that note is too soon now, or that note is too late, or it needs to be whatever. And so how do you coach a piece? How do you improve it? How do you re-remember it after you've been away from it for 2 years? What will stay is the kind of architecture of pulse that in the performance was completely unsounded, and what was sounding was all these things that I've hung on that architecture.
So I guess that's an open question for us, is does all rhythm need a beat to be understandable? Or are there some rhythms that you can get away with just reproducing the patterns without any
Well, I'm not a scientist, so I don't really know the answer to that question, but I do know that rhythm that rhythm seems to be a human enforced perceptual framework on any kind of sound. Sometimes those sounds are made by humans for human perception. So like a drummer going, knows that pretty soon somebody's going to light a lighter and do this. It is rhythm made by a human for the consumption of humans. But if you listen to natural phenomena, for example, if you listen to the sounds of waves crashing, if you listen to something that doesn't care about us, then we still impose rhythm on it because we are periodic creatures. We have rhythms that are created by the rhythm. We have a periodic sense created by the rhythms of walking. We have another much slower sense created by the rhythms of breathing. Our endocrine system cycles around. We are a bag of rhythm. And so when we hear things, whether rhythm is intended or not, we impose structure on it because this is our perceptual mechanism. Pulsars that come in essence, proving the periodic nature of the universe, coming from deep, distant space. I'm wondering if they reached a species that did not have the periodic capacity and perception that human beings did, whether it would sound just like a jumbled mess. To us, we hear, we latch onto it because it's something that we see in ourselves. So I tend to be a strong believer just from a phenomenological standpoint in the perceptual grid that every human perceiver lays down on any sound, whether it's intended to be rhythmic or not.
Let's hang that thought up, because I think Ani will do that later when we talk about humans versus other animals.
Great.
Okay, so let's talk a bit more about the brain. One thing that really drives our work here at NSI is this question: what happens in our brains as we make or listen to music? And I just want the motivation for this is, of course, we're very interested in music and understanding what makes music tick. It's definitely something in us. But we're also very interested in using music as a tool to understand the brain in general. If you think about what's happening in your brain as you listen to music or make music, Ani mentioned it touches on memory and emotion. There are all sorts of perceptual processes, understanding the structure of the sounds. There's movement, the strong connection between sensation and movement. So it actually turns out to be a really great playground in which to understand, or try to understand, many different general brain processes. Okay, this is what we're talking about. As I showed in that video before, there's something about music that makes us want to move, even babies, right? And we're really trying to understand why that is on a couple of levels. The big why is rhythm and dance found in every culture? Why do we do this? Why do humans do this? Was it evolved for some reason, or did it come along for the ride with another evolved trait? And I'm going to be talking about that a bit later. Some of the ideas about the evolution of rhythm, actually, that drill team up there, that's one idea, that it helped early societies bond together and coordinate their actions during hunting and warfare. That's one idea. There's certainly an incredible feeling of togetherness that you get when you're dancing with people or making music together. So there's some, it's very powerful, it's very deep within us. But then there's this slightly smaller question of how. How do we make this structure that Steve was talking about, this internal architecture, this metrical grid, whatever, this internal thing that we use to understand rhythms? Where does that come from? How do we make it? What is our brain doing when we talk about feeling a beat? And finally, something that's very exciting is that because music really touches all of us, it's gaining a lot of use in medicine, in therapy for various disorders, such as Alzheimer's. But I'm just showing a video now of one use of rhythm and the beat in helping people with movement disorders. You've all heard of Parkinson's. One of the problems with Parkinson's is actually walking becomes very difficult. It becomes difficult to initiate walking and then to maintain a steady rhythm. So Steve talked about we all have this rhythm in us. Well, what happens when that rhythm disappears, right? That might be one way to describe Parkinson's. So can we use music as kind of an external clock or rhythm to re-entrain a person's movement? So in this video, this woman suffers from Parkinson's. She has some of the traditional symptoms, sort of poverty of movement. She's standing there. Seems like she wants to move, but she's not able to initiate it. But with some help, you feel how that's what we said too. Wow. So, how does that work? And is there a way that we can make it better? Before I get to the rhythm and beat, I just want to talk a little bit about perception in general. Basically the idea that, well, it's a question that's been around for a long time. When we perceive things, are we really perceiving, the truth, the reality out there? Or are we always adding to it, embroidering it, or interpreting it? I think everyone would agree that we interpret things. We're not a tape recorder, we're not a video camera. For example, one way of saying that is perception is constructed. What we perceive depends on the world and on what's going on up here. So here's a common illusion. It's called a phase space. If you pay attention to the green color, you'll see two faces in profile looking at each other. But if you instead bring the red color into the foreground, you'll see a base, symmetric base, okay? So, of course, the photons striking your eye, your retina, are not changing. What's changing is what you're doing with this information inside your head. And the same thing happens with rhythm. And I guess I'll go out on a limb and say rhythm is really just pattern of events in time. They might have different weights and things like that, but that's almost getting into territory of interpretation of the beat. But this is a rhythm, for example. The simplest rhythm would be just an even beat, right? Okay. Well, if you leave out every other beat, you still have an even beat. But if you leave out every third beat, you get something suddenly very interesting. But it doesn't really have a beginning or an end. So listen to this and just kind of get a feeling for where would you tap your foot when you were listening to this rhythm. Self-destructive. Didn't realize that was quite so long. So these little blocks are a way of showing when the sounds happen. There's sound, sound, wait, sound, sound, wait. And you might have heard it with a beat on one of those sounds, but there's really no more information in this sound than sound, sound, wait. And we can write it like that in music notation. But still, there's something missing. And so what's missing is this idea of beat, that as soon as you start hearing a beat, saying, whoa, one of those notes is actually more important than the other. You can then break this down and hear this identical rhythm in very different ways. So for example, if you heard the beat on the second note of this pair, and I'll indicate it in this case with a slightly louder volume. Okay, it's a quite traditional way of the music telling you where you're supposed to hear the beat. Okay, it's like a skipping or a swing, even a heartbeat. Okay. It's multiplying. Okay. But you could hear the beat on the first note. Da, 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 da. And so, did you hear the difference?
Yeah.
Yeah, for sure. One has an upbeat kind of sound. It's got an upbeat. And the other one is a much more martial, sort of straight down, da, 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 da. Well, for illustration, I made those notes louder. But in the actual experiment, you can tell people, hear the beat on the first note, hear the beat on the second note. And they're hearing all the notes that are the same volume, but they impose that structure on it. And the marvelous thing is actually those accented beats, they disappeared after a while. And you still held on to that structure. Okay. And so you can actually hear this pattern of notes in completely different ways, depending on what you're doing in your brain, where you're hearing the beat. Okay. So just remember these colors. Red is hearing the beat on the second note, blue is hearing on the first note. Okay. Well, one thing that we kind of think naturally is if I wanted to demonstrate a beat, I'd probably move somehow, right? If I was going to demonstrate that second rhythm, I'd say da-da, 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 da-da. So we know that our motor system is pretty good at creating beats, okay? Creating some periodic movement. So the question that we have is whether hearing might involve the motor system. If you think about the process of, say, clapping along with music, you hear it, you perceive a beat, and then somehow it gets over to the motor system and you can produce a beat. Well, we're really interested in the idea of whether there's connection in the other direction. Not just stimulus to response, but maybe something that we're doing internally with movement can actually affect perception. Okay, so we're interested in this sort of backwards arrow, so to speak. And what's particularly intriguing is whether that's happening all the time, even if we're not moving with the beat. Okay. there's internal activation of the motor system, even when we're not moving.